Here we've got a quadratic equation again that we're going to be using. We're told that is a model rocket is launched with an initial upward velocity of 47 meters per second. That's where this 47t is coming from. The rocket's height h in meters after t seconds is given by this following. And the negative squared, that's the force of gravity pulling it back down. So find all values of t for which the rocket's height is 27 meters. So we could do this in two different ways. You could plug in 27 and then solve it for t. We could do that. You can also graph this, do it as a graphical look. Let's go ahead and take a look at the graphical approach, and then that way we will also take a look at the analytical approach using the solving the equation by hand as it is. So we're going to clear this out. I guess before we start all this, we have to say, what are we trying to do? We want the height to be 27 meters. So that's 27 equals 47t minus 5t squared. One way of solving these is to graph both sides, actually any equation. If you graph both sides of an equation, the left side as y1 and the right side as y2 as a second equation, wherever they intersect each other, that's where they're going to be equal. So that's the key part of this. So y1, we're just going to put in 27, and in y2 we will put the 47x minus 5x squared. That's that other equation. Now let's think through this a little bit. Where y is up at 27 is the intersection we're looking for. So when we look at our window, we definitely want our y maximum bigger than 10. Be able to see everything. Let's just go to 50. That's plenty good. We know we will definitely see 27 there. We're going to leave the x's at negative 10 and 10, hoping it happens within 10 seconds. If we don't see enough, we will change those. Okay, so our x's are going from negative 10 to 10. Our y's are going from negative 10 to 50. Graph it, and we do see it. We have just enough. We see this. If we wanted to go up higher, we'd actually see the whole height of the rocket. If we were maybe looking for maximum, we'd need to do that. But in this case, we just need to find the two intersection points. There's two times, one when it's going up, and then the other time when it's coming down, that it is equal to 27. So going up and coming down. So second calc is a way to do it, and we look for the intersection, number 5. We'll hit enter. For the intersection, it asks for the first curve. We are on the horizontal line, y equals 27. We will hit enter. Notice it jumps over to the parabola now. It's asking, is this a second curve? It doesn't matter really where it's at, but yes, that is the other curve we want to have the intersection of. And since it's right there, we could just hit enter for the guess, and it will look and it will find that intersection. It'll find whichever intersection it's closest to. So we're going to hit enter, and there it is. It's the seconds are the x values or the t values, in this case 0.61466, and we are supposed to report this to the nearest hundredth. So we're going to go 0.61 as the first one, but we're not done yet. But let's record it. 0.61. Okay, that's good. And it says there's more than one, use the OR button. So let's put that, or let's find the other one. Now to find the other one, we do the same thing. Call up the tool again, second calc, number 5. You could just hit the number 5, and now it is calc intersect. It's saying it up here. Where is the first curve? I'm on the blue one. If you're not sure, just go hit the right arrow. Oh yeah, I'm on the horizontal line. But I want to get over to the other side because it's going to find whichever intersection I'm closest to. So if I hit enter, enter again, it'll find exactly the same one. I want to walk my little spider over to the other point. I'm going to hit enter, and then it jumps onto the second curve. I don't see it, but notice the y is 54. It went up here somewhere. I don't have to see it. I'm just going to hit enter because I know it's on the red curve. It's on the parabola. If you didn't have a color calculator, if you don't, you wouldn't see the color, but you would see that it is on Y2. So we'll hit enter. And then we've got Y1 and Y2 as our two curves, two graphs. And when we put enter, it is now closest to this one. That's the one it found. 8.79. We're going to round that 8.79 seconds. It's back down to 27 feet. So it hit 27 feet first, went up higher, and then came back down. 8.79. An alternative way. Again, if you've got a graphing calculator, that's what I'd go toward. I mean, we're going to need to use a calculator anyway, and probably the other way is using the quadratic formula if you don't have a graphing calculator. It's going to be a little bit more involved, but we can do it. We would start with this equation. We will get it equal to 0. That's the way we go about solving any quadratic equation. So we get 0 equals 47t minus 5. Let's, since we'll need to use the quadratic formula, let me go ahead and put the t squared first. 47 is going to be plus 47t, 47. And then minus 27. And we can solve this. It's not going to factor. I mean, we kind of see this because of the values we get. But yeah, I think it's, you could spend some time. I think you'll very quickly see it's not going to factor. So we could graph this as it is and find the x-intercepts, because right, this bringing the 27 over, that is basically taken the same thing and moved it down to the x-intercepts. And we will get these same values. But if we're going to do it graphically, why not just do it at the beginning, right? Start with this and graph both sides. That's my preference. You could graph this and then find x-intercepts. Okay, that would work. Or you could use the quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac over 2a. It'll work. A is the number in front of the t squared, b is the number in front of the t, and c is the number by itself. And so plug into this, we would get x equals minus b, so that's minus 47, plus or minus the square root, 47 squared minus 4 times negative 5 times c, which is negative 27. All divided by 2 times negative 5. Okay, so let's do the inside part here. We can see we're going to get x. 2 times negative 5 is going to give us negative 10. We're going to get the negative 47, it's going to stick there. And then we're going to add and subtract this number, which let's go ahead and get that. This over here so I can see what to plug in. Second quit. We're going to take 47. We're going to square it. We're going to, actually, let's just do the whole thing. I guess you could do this in pieces, but let's take the square root of 47 squared minus 4 times negative 5, and multiplication, the parentheses should give us our multiplication, minus times negative 27. We're still going to have some kind of a negative, and we can just come out of here, and we get 40.853. Since we're going to round it to 2 decimal places, we should go far enough out. So and that's what it says, round your answers we're going to round to 2 decimal places. Go out at least 3. Let's go 4, I guess. And bring this back over here. That's going to be 40.8534. Okay. Then we're going to add this number and subtract this number. So let's do that. So we're going to get negative 47 plus 40.8534. We should put a parentheses around that. So I didn't make it into a fraction. I need to insert something, so I'm going to go second INS, which is insert, put in my parentheses. So there's my numerator divided by negative 10. And we get our number 0.61, which we got over there, right? So one value is equals 0.61. That's one answer. And then we get the other one by, actually we could just come up here. Let's copy it. We'll go up there, highlight it, enter, and then let's just change this from a plus to a minus. And you should get the other one, 8.79, 8.79. So 2 ways to go about it. 79. And if you like using the quadratic formula, it's there if you can memorize it, or we can use the graphing feature of our calculator to find the intersection at the top.